Hey, welcome. This is your LI AI. Today we are going to learn Uber system design in about 10 minutes. Interview ready? Now picture a stadium letting out 50,000 phones open the app at once. Meanwhile, a million drivers elsewhere are already pinging GPS every 3 seconds. That fire hose alone, about 330,000 writes a second, and candidates still say post location into Postgres, then select nearby with hover scene. So what happens? The query never comes back, and two riders still double book the same driver. Imagine that nightmare. Two people walking up to the exact same car. The naive design sounds tidy, right? Rest location post, a driver's table, a distance query, a trip row. Sounds easy, wrong. The whole interview falls apart. HTTP handshake tags on a 3-second ping, O of N geospatial math, and a race on a sign. Today's real problem is not billing or login. It's ingesting a hostile location stream, answering nearby in constant time, and locking a driver atomically. By the end, you should redraw the board cold and defend H3 indexing plus the double book lock. Alright, let's lock requirements. So, requirements, keep the core list tight, then check with the interviewer before you invent a whole marketplace over coffee. Functional 1, ingest driver locations at scale, hundreds of thousands of writes per second, freshness in seconds. Functional 2, nearby driver query for a rider, a short list with a rough ETA, not a perfect global sort of a million rows. Nobody needs that in the room. Functional 3, atomic ride assignment, one driver, one trip. No double book when two riders confirm in the same millisecond. Below the line for this interview, payments, identity, full turn by turn navigation, and deep ETA machine learning. Name them so you sound product aware, then park them. Seriously, park them, non functionals. Pin the forcing number, about 1 million active drivers pinging every 3 seconds, roughly 330,000 location writes per second. Matching still has to feel interactive under stadium spikes. For location pings, prefer availability and low latency over perfect consistency. If we drop a ping, another arrives in 3 seconds. For trip assignment, we need a single winner. No debate what you'd actually say out loud. Focus on location ingest, geospatial nearby, and atomic assign. Payments out of scope, PAEL for pings, atomicity for trips. Next up, AP is and entities. AP is and entities. Keep the payloads boring and the traps loud. Location stream, the driver opens a WebSocket or server sent events channel and sends latitude, longitude, timestamp, driver ID about every 3 seconds. Do not sell a REST post per ping. That handshake tags is the first trap. And interviewers love watching people walk into it. Nearby, get rides nearby with lat and along. Response is a small list, driver ID, rough ETA seconds, maybe the hex cell, backed by an index, not a table scan, wearing a trench coat. Request ride, post with rider ID and pickup. Success returns trip ID and driver ID. Conflict 409 if the chosen driver just got locked. That status code, that's how you prove you thought about races. Entities you'll name. Driver location, driver ID, H3 cell, coordinates, status, hex driver set, the Redis set of drivers in a cell, trip ID, rider, driver, state. Say the trap out loud, accepting location as Postgres, inserts invites, both write meltdown and hover sign fantasy. Next, back of envelope, the numbers that force the boxes. Back of envelope, 2 or 3 numbers. That's it. Don't turn this into a spreadsheet performance. 1 million drivers times 1 ping every 3 seconds is about 330,000 rides per second on the location path. That single line kills Postgres as the hot store for current location. Done. Nearby cannot be distance math over a million points. You need cells, map lat long into an H3 ID, keep drivers in a set per cell, expand to a one ring of neighbors if the home cell is thin. That's O of 1 plus a constant, not O of n stadium scene. Tens of thousands of rider opens hit matching CPU. You will not auto scale out of a vertical spike in time. Later we'll note surge as load setting. Not just pricing theater. Say it in the room. I size the fire hose before I draw Redis. 330K writes forces the ingest path. Cell lookups force the index. Now, high level design. High level design, only the box is the physics forces. If a box isn't forced, it doesn't belong on the board yet. Driver app holds a WebSocket or SSE link into an edge gateway. Pings drop into Kafka as a sock absorber because stadium spikes do not wait for every consumer to keep up synchronously. A location consumer reads the stream and writes the driver's current location into Redis. Historical pings can drain asynchronously into a cold lake for machine learning. Fast path and slow path stay decoupled. That's the move. On write into Redis, we convert lat long to an H3 cell ID. We set the driver cell and we add the driver into that hex's active set. If they moved cells, remove from the old set. Current location is memory. We do not need disk for matching freshness. Rider path. Matching service converts pickup to a cell, reads the home set, then the 6 neighbors if needed, ranks a tiny candidate list, then attempts an atomic lock on the chosen driver. Success creates a trip record in a durable store. Failure, pick the next candidate. Keep moving. Rename test, and I love this one. If you erase H3 Kafka and Redis current location, this becomes generic CRUD. So those boxes stay. Payments and notifications hang off trip creation later. They are not today's bottleneck. Alright, deep dive 1, the geospatial index. Deep dive 1, geospatial indexing, wrong versus correct. This is where coffee gets serious. Wrong, select drivers where latitude and longitude sit in a bounding box, then have a scene sort. At a million drivers, that is a scan dressed up as a squirrel. It will not meet an interactive SLO. The query just stares at you, correct. Project 2D coordinates into a 1D cell ID. Older systems use GeoHash squares, prefer H3 hexagons. Neighbor distances are uniform. So a K-ring search is cleaner than square corner bias. Driver ping becomes compute cell, store on the driver key, S add into hex drivers, rider query becomes compute cell, S members, maybe expand one ring, then cheap rank on a handful of candidates. Staff note, if they poke Y hexagons, give one sentence, equal neighbor distance, cheaper radial expansion, and say what you are not doing. Perfect global nearest neighbor. Product needs good enough nearby under a fire hose. Not a PhD thesis on the whiteboard. Next, double booking. The visceral one. Deep dive 2, atomic assignment, stadium empties, 2 riders confirm the same driver in the same millisecond. Here's where it gets messy. Wrong, matching service reads driver status available, then writes a trip. Both readers saw available. Both wrote double book, classic check, then act. 2 humans, 1 car, awkward sidewalk conversation. Correct a Redis Lua script or optimistic concurrency check that in one atomic step verifies available and flips to locked by rider 1 with a short TTL, say 15 seconds, while the trip row is created. Rider 2's script sees not available and slides to the next best driver. No long Postgres lock on the hot path. Beautiful. Optional staff spice. Surge is not only revenue, it is load setting. Raising price cuts demand so matching, CPU survives the flash mob. Economics as back pressure. That sentence lands. Quick practice beat, then we close. If you want to practice this loop live, boards, probes, timed mocks, sign up on YourAlly AI at yourally.live. Written boards for Design Uber also live on YourAlly Academy. Alright, closing checklist. Recap what you say when they ask you to summarize. WebSocket ingest into Kafka, current location in Redis, H3 cells and neighbor sets for nearby. Lua or OCC so two riders cannot claim one driver. Location pings tolerate loss. Trip assign needs a single winner. Payments named and parked. 3 probes. Firehose size 330K rides. Nearby cells not ever seen. Double book. Atomic lock with short TTL. Academy lesson. Your Ally Academy. Design Uber. YourAlly.live/academy/system design/design Uber. Practice until the answers feel boring. Boring is the goal. Thanks for watching. Go redraw it cold.